Hello, my name is Cyndy Brown, and today we're going to be bringing you a program called Stargazing. I know when I was a little girl, one of the most interesting things to me was the sun and the moon and the stars, the planets, how many there were. I always wondered where the stars came from and what really was a star. And I always wondered about asteroids and meteors and all those kinds of things growing up. Then when I became a teacher, I found that all the students that I've had share interests that I had equally. And whenever we do a unit on the solar system or the planets, I see students that are very eager to learn. So a few weeks ago, I came across a group called the Down East Astronomers. And they were a local group of people who study the stars and the planets from right in this Washington County area. And I invited them to come to the classroom in grade 5 at Woodland Elementary School and share what they were doing with my students. As a result, I learned a lot, and I know that my students did. So I have invited Frank Davenport and Charlie Sawyer here today to tell us about what they have learned as they have studied astronomy using some of the equipment that they have acquired. And we're going to share some of this information with you today, and I hope you enjoy the show. Good afternoon. I'd like to introduce Charlie Sawyer, Frank Davenport, and first of all, I'd like to thank you both for taking the time to come here today. I know you're very busy with your schedules and share all that you're going to with us today. The first question I'd like to ask is, when did you first become interested in studying the stars and planets? And I'll ask Frank first, and then I'll ask Charlie right after I finish with Frank.
I started being interested in the stars and probably when I was in grade school. We used to set out, or I used to set out at night when I lived in Aroostook County and watch the meteors falling and the moon coming up. And it was really interesting to me at that time. I haven't lost any interest, and in fact, hopefully I have gained more.
Great. Charlie, when did you start becoming interested in the stars?
I was somewhere around the age of 10 or 12. I can remember looking out at the sky when we moved into the country. We used to live in the Bangor area, and when we moved down east to the Pembroke area, the sky was so much more clearer. You could see so much more stars. And that's basically when I really became interested in astronomy, trying to learn the constellations. I can remember my first telescope was just a tiny little thing with a little tiny tripod that I put together myself that I could set on top of a table, and it was fun to create an interest like that, and it's been quite a while, and it's been a lot of fun too.
Did either of you remember ever doing a unit like this in school or anything? Did your teachers ever introduce you to any part of it?
What I got, I more or less got out of the encyclopedias myself and just, basic self-taught experiences.
Mm-hmm. And the same with you, Charlie? Or?
I can remember some different periods in school that we did go over planets and stars, and it always interested me. I think my oldest brother was a big influence on me because he was kind of like the scientifically minded one in our family, and I always asked him to point out constellations to me when I was small, and so that's really where it got going for me.
So how did you and Frank meet? How did the two of you get together so that you knew each one of you were both equally interested in this area, and you started getting together with this astronomers club?
I think what brought us together was Hale Bopp, and the school in Charlotte where I was employed was going to be studying space this particular year, and I thought that I would have a influence on all the children up there, all the kids and the teachers and some of the parents, if I would build something spectacular for the first day of school. And what that was a replica of the space shuttle that now flies freely over the United States and the world. And that first night, there was a school opening, and I think Charlie came up that night with his telescopes and was going to set out for all the kids to look at Saturn, I believe. I'm not sure now. And that's how I met Charlie. That was it 2 years ago, Charlie?
Yeah, it was about 2.5 years ago, and I did set my telescope out for the students. They were studying astronomy at the Charlotte Elementary School, and my telescope was set so I could plug it in the clock drive that the scope was mounted on, and I left it so all the kids could just take turns and view when they wanted to. And I walked into the gymnasium at the school, and that's when I saw Frank and this replica of the space shuttle, and I thought it was fantastic. It was a fantastic piece of work. And that's where we met and decided to start a club.
And that was 2 or 3 years ago?
Yes.
Or, yeah. Okay. In a little bit, we'll be looking at some of the pictures of your space shuttle that you created. And right now, what I'd like to do, though, is I'm excited about actually seeing your planetarium. I understand you have a planetarium that you've built with a large telescope. And what I'd like to do is just take a few minutes right now and go out and visit the planetarium. We'll be right back. I'd like to welcome everyone to the Star Room. I'm going to go inside right now and talk to a couple of men, Charlie Sawyer and Frank Davenport, about their planetarium, their observatory. Here I have Charlie and Frank, and we're going to be talking about how this observatory came into being. First, I'm going to talk to Frank for a minute here, because I guess you are the one that actually built the observatory, or put it together, so to speak.
Right. I purchased it as a kit, and then we put it together, Charlie and I and a few other folks.
Great. You were telling me earlier, Frank, that this telescope did belong to somebody else first. Can you tell us how you came upon knowing about it, or?
Well, it's my stepson lives in Topsfield, and his father-in-law knew the gentleman that owned the telescope, that bought it originally brand new back in the middle part of the 50s. And the gentleman now is in a nursing home in Lincoln, and he wanted to know that this telescope would be used free of charge, more or less, for anybody that was interested in astronomy. And I wanted a telescope, so we purchased it.
Who named the room the Star Room?
The star room itself was, there's a little star on one of the walls, and there was a room, the word room under it, so we just more or less kept the name star room. And it seemed to work, everybody likes it.
It's appropriate. As far as the building and the position of the building and the placement of the building, is that significant? Why do you have it exactly right here positioned?
The reason I put it here is more or less just security reasons. I can see it from my house.
Mm-hmm.
It's close to the road so that people don't have to go too far off the road to get to it. Anybody that is interested, you know, can come here anytime they want, as long as it's a clear night.
And obviously you do have a good view of the sky here.
Yes, we do.
Okay.
Yes. You have to have a good southern view of the sky. That we do right here.
Of building an observatory, how long was it from like the inception of the idea until it was completely in use and you were here with your group?
That was about 30 years. But we actually found the telescope last November, a year ago November. And we could not move it during the winter because the telescope itself is sitting on a cement block inside of the building. And the block is 3 feet into the ground, and the cement block is, and I'm lucky because it's right on the ledge. And then it's 2 feet square. The telescope has to be secured so that the frost will not heave it and it'll stay on tracking. So from the time we found the telescope in November, I moved it in a year ago in April of 1997.
How many people can you fit in here at one time?
Comfortably, we've had approximately 12 people. And with the steps that we have to use to go up to the eyepiece, it's quite crowded. And any more than that, they're bumping into the telescope, so it could knock it off of whatever you're trying to observe. And it's just better, no more than 12. But we welcome more, if we busload if we had them. They can stand outside, and we have other means. We have smaller telescopes and binoculars, so we would accommodate as many people as want to come.
Great. Is a map that the Down East amateur astronomers use to locate constellations in their planetarium. And this was drawn by you, Charlie?
Yes.
Could you tell us a little bit about the map?
Well, it's made on a shade. I found the shade in my basement and thought I'd put it to good use. It has a total of 59 constellations on the map, 567 stars. And these are the constellations that we can see from our latitude here at 45 degrees above our equator.
Every one of them? You can see every one of them?
We can see every one of those, not all at the same time. Different times of year we'll see different configurations of constellations. We are in the spring time of year, so this region here is what we will see in the evening sky currently, this time of year here in May.
Have you recorded some of the constellations that you've seen? Of the 500? Do you have a ballpark figure of how many?
Well, actually there are 88 constellations in all. We can see about 65 here on our latitude, and unfortunately a lot of them are down along the southern horizon, and the atmosphere is much thicker towards the horizon, so that making out the constellations are much more difficult. I put about 59 on this chart because these are the basic ones that we can see the best, and I didn't put all the stars, but I put the basic asterism shapes, the ones that we can make out clearly.
Have you seen a good number in this planetarium?
Oh yes, we can see, we've been here year round, and we've seen them all.
Great.
And we like to try to show them to all the people that come. So.
Charlie, can you tell us what we're looking at right now in this telescope?
Yes, we're looking down into the tube of the telescope, and we are looking at the large 12.5 inch paraboloidal mirror that is the objective mirror, the primary mirror to this telescope.
Okay. How wide is the lens on this?
The mirror is 12.5 inches in diameter, and there are actually two mirrors in the telescope. There is one mirror down at the end of the tube, the 12.5 inch mirror, and there is a smaller mirror that we refer to as a diagonal, and that is up at this end of the tube.
How much can this telescope actually magnify something? How many times?
Well, it varies. It depends on what we have in it for an eyepiece. We can go from 50 power to 600 to 700 power. It depends on what we're looking at astronomically. For example, with the moon, we might want to use a large amount of magnification to bring the moon in close so we can see right down inside of the craters.
Just as an example, for a comparison, with a video camera, you can usually magnify about 14 times. So when you start talking about 700, 500 times magnification, you're really talking quite a magnifying glass here. Could you tell us about the telescope, the technical aspects of it, what kind it is, and what it can do?
Sure. It's a Newtonian telescope. It was the type of telescope, the design optically was first invented by Isaac Newton back in the mid-1600s. And the large mirror that we looked at earlier down at the bottom of the tube is a paraboloidal mirror. It has a concave surface. So when the light enters into the mirror from whatever celestial object that we're looking at, it is reflected, but it is also bent to a focal point. And when the object is reflected off the large mirror, it comes back up the tube into the secondary flat, which is angled 45 degrees, and that is facing out towards the focusing mount, where the eyepiece is put in place. This whole process is called focal length, and we can determine the focal ratio of the telescope by knowing the focal length, which is about 1,800 millimeters. And by knowing the focal length of the telescope, we can also determine our magnification with whatever eyepiece we put in, and that's how we achieve the magnification.
Super. I know a lot of people don't like to talk about finances, but how much money would you say you've got involved in this, or is it a costly venture to make your own planetarium?
No, it isn't. This particular one right here, probably between $500 and $600. Everything that is in this building can be bought local, right in Calais. The roof is corrugated fiberglass. The rolls are just rolls that you would use on a clothesline, and the track is a half-inch conduit. The rest of it is just 2x4s and a little bit of paint, which we're going to do later, floor, and that's basically it.
And a little Yankee ingenuity.
Right.
Well, I don't know about you guys, but the bugs are really driving me crazy. Let's get back to the studio. Here we are back in the studio, and I'm really thankful because the bugs are really thick out there. Frank, when you were talking about the financial part of building the planetarium, and you were explaining how much money it would cost, were you referring to the telescope included with the building?
I'd like to clarify that. No, the price that I quoted was between $500 and $600 for the building. That particular telescope that we have out there, probably in today's money, was probably right around $2,000 to replace it.
Okay, so it's pretty expensive, really, even if you're just going to go with the bare minimum to study the stars, although that is an impressive telescope. What if you were a young person, just a young child who was interested in studying the stars, and you had your books and everything, but you really wanted to go out into the night sky and look up and be able to name a constellation or to find a planet, and you didn't have access to a telescope or access to a club or transportation, and you didn't really have anybody that could teach you. Is there anything that they could use that's around the house for tools that they could be on their own as an individual and learn about the stars?
Yes, there are several things that you could do. If you wanted to study the constellations, find out where the stars are, your total cost for that would be approximately $4.95. What you would do is go down to the local bookstore, and you can buy a magazine called Sky and Telescope or Astronomy. And in those magazines there is a pull-out section of the northern and the southern hemisphere of all the constellations that you would be able to see from where you are sitting. Sometimes you look up there and you can see the Big Dipper, and if you want to memorize that Big Dipper, you have just a regular household flashlight. And in the summertime, there's enough humidity in the air in the evening that you can take that flashlight and shine it in the air and draw the Big Dipper. You can draw just about anything, any constellation that is up there that you can see.
That's fantastic. So I hope that some of you young people that are listening to this program, if you're interested in learning about the stars, you know now ways that you can take it upon yourself to go ahead out at night in your own yard and look up and learn about the names of the constellations. What I'd like to do right now is to ask Charlie if he would Tell about some of the more sophisticated instruments that you use in studying the stars with regard to the telescopes. I understand that there are two major types of telescope lens, the refractor lens and the reflector lens. And what I'd like to have you do, Charlie, if you would, is to tell us about the differences and maybe draw a diagram so that the audience could really see what you're talking about.
Certainly. There are two basic types of telescopes, the refracting telescope and the reflecting telescope. The refracting telescope does use lenses, and the reflecting telescope uses mirrors. And I will be very happy to draw the difference between the two. The refracting telescope was first invented back in the early 1600s, and a man by the name of Galileo Galilei was one of the first ones to use them to look at astronomical objects. The refracting telescope is simply a telescope that has a lens up to the upper end of the tube and a lens down here at the lower end of the tube, which we refer to as the eyepiece. And let me just write this in here. The refractor and the reflector. The refractor generally has a lens up at the upper end which is convexed, so when the light enters the lens, it is bent or refracted down to the eyepiece, and the eyepiece simply magnifies the image which comes through the lens. For example, if we're looking at the moon, the image of the moon would come through the refracting lens, and the light from the moon would be refracted or bent down to the eyepiece, where the eyepiece would magnify the image of the moon. This type of telescope is very similar to telescopes that are mounted on guns, spotting scopes. Any type of birding scope is basically a refracting telescope design. The reflecting telescope is a little different, and the one at the Stargazing Observatory in Charlotte is referred to as a Newtonian telescope. The Newtonian telescope was first invented in the 1600s also by Isaac Newton, and that has a large mirror down at the bottom end of the tube. The top end of the tube is open. There are no lenses or mirrors at the top end of the tube. When the light from an astronomical object, for example the moon, enters the tube, once it hits the mirror, it is then reflected back to a secondary mirror about 3/4 of the way back up to the tube, and then the light from the object is reflected back out again to the side where the eyepiece is mounted, and this whole process is the Newtonian process for the Newtonian reflector. And this is where the eyepiece belongs here. That's why when we were up at the star room, you saw we were looking through an eyepiece that was up at the upper end of the tube, instead of down here, the usual conventional place where the eyepieces are found.
During this segment, I'd like to talk a little bit about stars and constellations. Charlie, if I could pick your brain for a little bit, what is a star made from?
Well, stars are balls of gas. Hydrogen, helium, it really depends on the mass of the star, which really determines what it's made of mostly. But hydrogen and helium are the most abundant elements in the universe, and just about every star has that.
How is a star born? I've heard that stars can be born at any time in the sky and then they die. Could you tell us about maybe the birth and death of a star?
Well, a star is born generally from a gaseous material that is intertwined together from the death of other stars. For example, we've all heard of a supernova explosion. When a star explodes and ends its life, the gases intertwine and new stars are born from those gases. That's generally the method.
What is a bright star?
Well, the term for a bright star would be simply a star that is brighter than most of the other ones. Some of the stars you look out at night, you can see that some are brighter than other ones, and that's referred to, we measure that as in a magnitude scale. The brighter ones are roughly magnitude 0 or +1, and the fainter ones are somewhere around +5 or +6.
Is a red giant bigger than a bright star?
A red giant star is a star that's in its latter phase of life. There's one famous star known as Betelgeuse in Orion, and if anyone is familiar with the constellation of Orion, a wintertime evening constellation, you would look up and see a red star in Orion, and it's very bright, but it's over 500 light years away. And what makes it interesting is that we can see a star 500 light years away, a red giant star, and we can also see stars that are only 10 light years away. Well, that tells me that Betelgeuse is obviously a very massive star, a very large star. The red giant has cooled and it's expanded outward. And if Betelgeuse was in our solar system, Earth, Jupiter, and even Saturn would be very true.
What is a white dwarf?
A white dwarf star is probably the end stage for our own sun. Our sun is a main sequence star and a very healthy middle-aged star. And a supernova, for example, will generally occur when the star is 10 solar masses or more than our sun. Our sun is a very normal star, and it will, for another 5 billion years, burn its nuclear fuel and eventually wind up as a white dwarf, which would be possibly no bigger than the Earth or Jupiter, but still shine with a white light.
Well, we wouldn't have to worry about getting sunburned, would we?
We wouldn't have to worry about sunburn.
I know that groups of stars are called constellations, but I'd like to know a little bit more about maybe how they got their name.
Constellations are generally named after Greek mythological animals and characters. And to think about when they were formed, we can think back to our ancestors, perhaps some tribesmen out on a hunting day, and at the end of the day, sitting around bubbling pots of meat, looking up at the sky. They didn't have television or computers in those days, so their entertainment was stargazing, and they would see themselves with their spears and their animals that they hunted. And this is where it all began.
Maybe how we look up in the sky during a sunny day and look at the clouds and try to pick out an animal or a figure that we do today. What is your favorite constellation?
Well, I really don't have any favorites. There are a few that I do enjoy looking at. The constellation of Pegasus the Flying Horse is a good one in the fall. And you can see where my pen is here. It appears upside down on this map, but that's exactly the way it would appear in the sky. The Big Dipper is a favorite of many. It's actually part of a constellation known as Ursa Major, or the Great Bear. And the handle of the Big Dipper is arced towards another constellation which is very interesting, Boötes. And that has a very interesting star known as Arcturus. And a simple method of finding Arcturus is by following the arc of the handle down to the orange star Arcturus, and these are spring constellations. Leo is another one in the spring, Leo the Lion, and it's a very easy constellation to observe, and it's at a comfortable time of year also to observe it.
Charlie, have astronomers figured out approximately how many stars are in our galaxy?
Billions and billions, as Carl Sagan always said, and that's very true. I don't think they have an exact amount, but it's definitely in the billions and billions.
Okay. Frank, it's your turn now. I'd like to talk about our favorite star, the Sun. Frank, how does the size of the Sun compare to the size of the Earth?
The size of our sun is about 180 times larger than our Earth.
How much, what is the distance around the Earth, the circumference of the Earth on the outside?
If we started from Woodland, Maine, and went completely around the Earth and ended up back in Woodland, Maine, we would average approximately 24,000 miles.
Wow.
If we took that same amount of mileage and went to the Sun is 13,000 times larger than the Earth.
So I could take 13,000 Earths and put them inside the Sun, and they would fit inside the Sun?
Correct.
Wow, that is massive. Okay, most everybody knows that with the Sun and the 9 planets that orbit the Sun, this is called our solar system, and we are located in the Milky Way. Charlie, what is the next largest galaxy in the universe?
Well, the next largest galaxy to us is referred to as the Andromeda Galaxy. It's about 2.9 million light years away. It's a galaxy that can be seen with the unaided eye on any fall evening. With binoculars, it's spectacular. But that's the next largest one to us. There are some smaller galaxies kind of in orbit around our own Milky Way and Andromeda. Andromeda and the Milky Way are the two big ones in our local group of galaxies. But Andromeda is the next largest one to us.
I know that light travels at 186,000 miles per second, but it's really hard to define what a light year is. Could you maybe give us a rough idea of how far that might be?
Sure. A light year is not a measure of time, it's a measure of distance. It's the measure of distance that light travels in a year. at 186,000 miles per second, that turns out to be about 6 trillion miles.
Quite a distance to travel. There are some other heavenly bodies out there in space too. Comets, meteorites, meteoroids, meteors, asteroids. Can you tell us about those? First of all, what is the difference between a meteor, a meteoroid, and a meteorite?
Okay, well, a comet, first of all, is an object that is from the outer edges of our solar system. Comet Hale-Bopp was a fantastic one that we saw a little over a year ago. It's very bright. It showed two tails, a white dusty tail and a blue ion gaseous tail. Both of those tails were caused from the energetic particles from the sun. A comet is an icy, rocky type object. It's like a cosmic taxi cab. When it does come into the inner solar system, it picks up a lot of interplanetary debris, and as it gets closer to the sun, the energy from the sun blows all of that debris off and creates a meteoroid stream. Now the meteoroid stream, we now come to the meteoroid. Meteoroids are small particles as a result of debris coming off this comet, which are actually parts of the comet and also some dusty interplanetary debris that was picked up as the comet made its way towards the sun. The meteoroids then form an orbit. They it's actually the orbit of the comet itself. Now as the Earth goes around the sun throughout the year, we enter into these orbits. And that's what gives us our meteor showers. And when we go out at night, if we see a meteor or a bright flash across the sky, a shooting star, whatever you want to refer it to, that's a meteor. That's a piece of debris entering into the atmosphere at very high speed, something like 75 miles per second. And the friction process, when that does enter into the molecular structure of the atmosphere, the friction just ignites it and we have a flash of light. If you see a real bright meteor at any given night, that's probably more of an asteroidal type origin. And that would be rocky metallic. And if it's really bright enough, it very possibly might have made it to the surface of the Earth, and then we come to the term meteorite. It does not become a meteorite until it lands and
Actually has an
hits the
impact.
surface. Exactly.
I went to a movie last night called Deep Impact, and in the movie there was a threat of an asteroid hitting the Earth's surface, and it weighed, I don't know, 18 billion tons of rock, and it was a pretty scary, thought about having something like hit the Earth. What are the chances, if you've studied it, I don't know, but what are the chances of an asteroid actually hitting the Earth and causing damage?
Well, they expect that every 50 to 100,000 years we could be impacted by an asteroid. And the last impact that occurred on the Earth was just about that long ago. That does not mean we are necessarily going to get impact immediately, but it isn't really a matter of, it's a matter of when. Because some of us have heard of the asteroid belt, which is out there in between Mars and Jupiter, but there are a lot of rogue asteroids that are in orbit around the Earth. And very possibly there could be a final rendezvous between the Earth and an asteroid. And it wouldn't have to be a very big object to create some damage. There's a crater in Arizona, a mile wide, that was created from an asteroid that was about 100 feet across.
Right now, Frank and Charlie are going to share some photos that they've taken for you, and I'll just turn it over to them and let them tell you about them.
Thank you, Cindy. This is a picture here of the Andromeda Galaxy. It's shown right in the center of the picture of the two to your extreme right. And this was taken on a clear evening, as you can see, and it's piggybacked onto the telescope. It's used with an 800 speed film. It's a 35 millimeter camera with a 30 millimeter lens.
Also a picture of the Pleiades star cluster. You can see it to the right there. It's also known as the Seven Sisters. It's an open star cluster in our own galaxy, within 100 light years distance. It's a fantastic object for binoculars. We used about 800 speed film on this picture also. And here's another picture of the same object with a little less exposure time. You can see that there are not as many stars peppering the view, but experimenting with the exposure times really makes a difference on taking better photographs.
This is just another picture of the same thing, only the exposure time, as you can see, is is a little bit longer there also, and is still with the 800 millimeter speed.
Again, the Pleiadic star cluster and a little more exposure time. The result of that is sometimes the fogginess in the center of the view. Okay, here we have a close-up of the moon with some mini craters. This was taken through the telescope with a process known as eyepiece projection, a process that mounts the camera up to an eyepiece so we can photograph a magnified detail area of the moon. The moon is our closest celestial neighbor at about 240,000 miles away. The orbit can be described as having a bit of slight eccentricity, which means that the Earth is not in the center of the moon's orbit. It's almost circular, but it's not. So the distance to the moon varies roughly about 225 to 250,000 miles.
This is a picture of the Great American Nebula. It's right in the center of your screen. If you look at it real close, you can see it looks like the eastern part of the United States. This is just a starry night that we were trying to catch some meteors, or maybe I think also that night was some northern lights. There we have a picture of it there, the tree line, and just above and to the right of the tree line and the telephone pole there, you can see some of the streaks coming down through.
The aurora borealis, the northern lights, are caused from the energetic particles from the sun. When they hit the Earth, they enter at the poles, and that's why towards the north and even in the south they can experience southern lights as well. This is Comet Hale-Bopp, the famous comet that everybody saw about 2 years ago. You can see the blue ion tail and the white dusty tail, which is also a result from the energetic particles that the sun emits. As the comet comes in towards the sun to go around the sun, the solar wind blows it away towards the comet and creates a tail. The tail is always opposite the sun, so when the comet's on its way back out, the tail is in front of the comet. It doesn't always remain behind the comet. It's not the motion of the comet that creates it, but the energy from the sun.
Space, the final frontier. 2 years ago, the Charlotte Elementary School was engaged in a year-long study of space, and I took it upon myself to build them something that they could relate to, all the children from kindergarten right up through the 8th grade. And what I did was I built a simulated space shuttle, and this is built out of wood, paper, paint, and just a little bit of hard work. We had lots of help doing it. I also took the specifications after I built this to Florida, and when I visited the Kennedy Space Camp, I showed it to the engineers down there, and with the measurements that I came up with, the space shuttle that we built here as a prop for the school, Charlotte School, is 1/10 the size of the original space shuttle. And this one that we built, its overall height was 19 feet 8 inches. It's 4 inches shorter than the gym in the Charlotte School. The booster rockets are 15 feet 4 inches. The shuttle height itself was 12 foot 8, and the wingspan was 11 foot 4. This stayed in the Charlotte School for, I'd say, for about a month. when the day that school opened up, we had a little simulated takeoff. We had borrowed a fog machine from the local radio station. They were very kind and generous and let us borrow that, so that when it came down for countdown, we had the big countdown, and then we pushed the button and the steam rolled out and the space shuttle took off and the kids went into orbit to learn about space for that year. Also, in the roof of the gym, which you can't see here, was 600 white lights that we had installed, and on a rheostat so that we could brighten or dim them. And also we had a little astronaut flying around up there at the same time. So it was, the first day was real exciting for the children there at Charlotte Elementary School. Now we're going to take you through the process of making a space shuttle replica. As I told you before, this was made out of paper, a lot of cedar pieces, of wood stripped down, and a little bit of ingenuity, some metal straps, and some good days, and some helpful people. We had a lot of fun doing this. It took about, from start to finish, it was probably 3 full days, but in the long run it took us almost 2 weeks to do it, and do it completely. This is part of the main booster that we made there. There's all the parts assembled now. Now they've got to be put together and they look like a simulated space shuttle and boosters, booster rockets. All we did when we did this was have a lot of fun. We tore it apart 3 or 4 times, we put it together, we had a professional painter, a nephew of mine. Everybody in the family, this was a family deal. The school was totally oblivious to what was going on. I told them that they were going to bring their cameras to school on the first day of school and be surprised. And I think I managed to surprise everybody. We had a real good time doing it. And maybe if things go right, we could do it again, and we gladly would let any school that was studying space or is going to study space, we'd gladly let them borrow it for whatever time they need, as long as they have a place to store it in a gym or in a large building, because it does take up a lot of space. It's 20 feet high and almost 12 feet wide. So you have to be able to handle it. We can transport it to and from school. And the name of the space shuttle was the Coyote, because the mascot for the Charlotte school was the Coyotes. And you can see on the wall there, and the space shuttle itself was called the Coyote. Kids all enjoyed it. It was a fun time for them. And I think most of the adults that came in and seen it enjoyed it. I know Charlie Sawyer, my friend there from astronomy, he was really impressed with it. So we're, in the future we're planning something even almost as big for this school year. It's going to be more in the line of the astronomy. It'll still be made out of paper, and it'll be made out of wood, and we'll just have to make believe. Everybody's going to have to use their make-believe brain, because we are geared for the children. All the kids from, from 3 to 103, I guess. You might ask what a space shuttle has to do with astronomy. It has a lot to do with it. The space shuttle has taken some of our best astronauts up there into space and studied different ozone levels here on Earth. It has taken one of the most expensive and the best equipped telescope into the air, and it's called the Hubble telescope. Without that, there's a lot of things that are now available to us that weren't if that wasn't up there. We have found new planets with the Hubble telescope. We have found black holes. We can now study black holes with the Hubble. There's a lot of things that they relate to each other. They are now trying to assemble a space station up there, which will, I hope, be a lot more trouble-free than the present one that's up there now. We are hoping this fall to have the replica of the Hubble Space Telescope in the gym again, and in the parades, maybe in Woodland and maybe in Calais, wherever they are wanted. They are free of charge to any organization, school, or what have you. We're happy to lend them out. We also invite anybody, everybody, to come out and look through our telescope. You can't see the flag on the moon like some people would like. That's all right. There's other things on the moon that we can see. We have all the books, star data that amateur would need, and we are pleased to welcome everyone, not only in Washington County, but anywhere in the state of Maine, New Brunswick, or wherever you live, to come and visit us anytime that there's a nice, clear sky in the evening, no matter what the time may be. Thank you very much.
Thank you for taking us on that trip with your shuttle and the process of making it. We'd like to talk a little bit now about your club. It's called the Down East Amateur Astronomers Club. Is that it?
Yes, ma'am. Yes.
Could you tell us about it, like when you meet, where you meet, and how anyone could get in touch with you to become a part of it?
Okay. Part of it is the building itself, the telescope, and the observatory is located on 214 in Charlotte. Just down over the hill, if you're going towards Pembroke, about a mile from the Charlotte Elementary School. If you're coming from Pembroke, it'd be a mile on your left from the railroad crossing. We meet there once a month, and we try to meet early in the evening, so that if you have to get up for church or whatever the next morning, and you're welcome to stay as long as you desire. We usually meet on a Saturday evening. We have been toying with the idea of maybe changing that to a Friday evening, so that if the weather is bad, then we can meet the next night. If you would like more information, and it's all free information, we have charts, star charts that are given out. We have newsletters. You can either contact me at 454-2450, or you can contact Charlie Sawyer, and he can give you the same information. And you are all welcome anytime that we have a meeting. And if you don't come at a meeting time, just give us a call ahead of time, and we will arrange it so that, providing the weather is decent, you will be able to see something or whatever you ask for.
Well, thank you, Frank. And right now, we're going to view a little bit of video about what it is like to be at one of your Amateur Astronomers Club meetings. And I think Charlie's going to tell us about that.
Stars like T9, T6, T8, T7.
Yeah, and the T, if you look over here, will stand from the top. Yeah. And it's a pretty dim star, exactly. And this is a very dim constellation. Eridanus, the river. And that goes way down into the southern hemisphere, too. We can't see that constellation completely. You can see it's next to Orion, so that would mean it would be, in the evening hours, a fallish into wintertime constellation in the early evening hours. Here I am with Thomas Harvey, a youngster from Dennisville. He is one of our members of our Down East Amateur Astronomers Club. Astronomy is the people science, and we have many people from many ranges of ages. Thomas is a good example of a very curious youngster who never misses a meeting, a very dedicated member of our club. He showed up with his 50mm refracting telescope to show us how he views the stars. Brought his eyepieces and all his equipment, some star maps and star charts, and even a planisphere, which we gave him free as we give to all of our members. Thomas has got the capacity to be an astronomer for sure when he grows up, and I think he's really looking in that line. He enjoys looking through the large Davenport reflector that's in the Star Room Observatory, and his mother and father make sure that they get into the meetings. Thomas also brought some pictures of the Orion Nebula. He gets Sky and Telescope magazine every month. He receives our club newsletter, which we make sure we send out every month with all of our information on it about the club. We also have Astro Trivia in the newsletter that I put in there at the very bottom of the newsletter. He's the only one that takes that on. I think no one else dares to. And he always comes up with the right answer. It gives him the initiative to research the questions, and he has never had one wrong yet. He's showing his red flashlight and all the equipment that he uses to stargaze, and he himself has seen a lot of celestial objects that most normal young kids his age do not get a chance to see. He makes sketches of things in his own yard, as he has told me about, and I'm sure he's eager to even get involved in some of our astrophotography programs. Just one of our members to the club. I'm here with Richard Metzpan, another one of our members from the back. Richard, tell me about your interest in astronomy and what brought you down here to our club.
Well, last fall I noticed in the Quantity Times an article about the club, and showed a photograph of this magnificent telescope. So of course I've never looked through a telescope, and I thought, that's what I got to do. Come down, look through the telescope, and see what it's all about. And since I have a sailboat, and I'm recently interested in sailing and celestial navigation, I thought maybe the club could help me find the various constellations that's of interest to mariners, and therefore I came down. I'm fascinated with what you have here.
It is quite an attraction, there's no question about that. The picture that was in the Quantity Times was fascinating, and
Yeah.
we were hoping that it did, and it has brought some new members. And you are familiar with marine navigation to some extent, and you're hoping
Yeah.
that the astronomy...
Well, we have GPS, and I also have Loran C, but I think the fascination with with sextant turned me on, and so this group coming down here and seeing your chart and all of this, I thought, well, why not? You know, it's fun, and see the moon through the telescope. Wonderful.
Fantastic, Richard. Glad you came down.
Okay, thank you.
Welcome back to the studio. Before we close the program, I'd like to ask Frank and Charlie, is there anything else that you two would like to add before we close the program?
The thing that I would like to add, Cyndy, is I would like to welcome you and your family and your school class to come out any evening that you would like,
Well, thank you.
and we'll show the kids a real good time.
Oh, great. That
Thank you
sounds
for
good.
having me on the program.
Thank you.
And that goes for everybody else out there too. We try to meet around the new of the moon so we get a good dark sky, but occasionally, even when the moon is out there bright, we'll still get together on a clear night. And if there's anyone out there that would like to call and make arrangements just to try to come down and see the telescope or look at the stars, feel free to do so. And thanks you also for being on the show.
Well, I'd like to thank both of you very much for all the time that you've put in doing this show, and thank you for watching. And if there's anyone out there that is interested in becoming a stargazer, there's nothing stopping you.